Okay, so we're going to be going over compound interest today. And your basic formula for compound interest is A equals P, 1 plus your rate to the power of T, where P stands for the principal, R is your rate, and T is time. So let's do a very first example. Let's say that I'm starting with $1,500 and my interest rate is 7%, and I'm going to let it grow for 6 years. Okay, so this is my starting amount. That's called your principal, okay? So 1,500, 1 plus the rate, you need to change it to a decimal. So if I move the decimal over twice, it'll be 0.07. And then your T is 6 years. So in 6 years, let's see how much money I'll have. So guys, you're gonna type this into your calculator and let me know how much it grew in 6 years. How much money do I have now? All right, so this is our total. That's how much your money grew. Your initial investment of $1,500 grew. After 6 years, this is how much is in the account. Okay, so guys, this is compound interest and this is annual. It's compounding annually, okay? So this is happening once a year. Now, you guys are gonna have other problems where it's not just once a year. It might be quarterly, meaning 4 times a year. It might be daily, 365 times a year, okay? So guys, that formula is P 1 plus R divided by N to the power of T, where N, this stands for the number of compounds a year. How many times is compounding a year? Okay, so guys, if it's compounding daily, that's happening 365 times a year, okay? So that means your formula would be 1 plus R over 365. 365 times T. This is if it's compounding daily. What if it was compounding monthly? What would you put? 12. This is if it's compounding monthly. Okay? So guys, this is the formula if they give you a specific number of how many times it's compounding. Okay? This previous one, it was just happening once a year. They didn't specify. So you're using this formula. But if they tell you how many times it's going to compound, you use this formula. So let's do an example. This is number 5. Your principal is $1,500 again. The rate is still 7%. Time, we're going to do 5 years this time. And your end value is 4. That means it's happening quarterly, or 4 times a year. Okay, so this is what you're gonna put into your calculator. Your principal, that's 1,500. Your rate as a decimal, move it over twice, you get 0.07. Your N is 4, so it has to be divided by 4. You have 4 up here, and your time is 5. So let me highlight what we used. This is the formula. Your N value was 4. That's why I put a 4 right here and right here. And then your time is 5 years. This is your time. Your principal value, that's right here. Okay, so guys, type that into your calculator and let me know what you get. If I compound the money 4 times a year and I do that for 5 years, and my interest rate is 7%, how much money will I have now? Okay, so when it was just 5 years, this is how much money I got. But if we want to compare it to the previous problem where we did 6 years, let's try it for 6 years. So I'm going to erase this and do 6 years, and let's see how my answer will change. So I'll put 6 years. And Ethan, when you did that for 6 years, how much money did you get?
2,274.66.
Nice. Okay, so if we compare this value of 6 years, and this value of 6 years, we got $20 more, roughly. So if you compound it quarterly, instead of just one time a year, you'll have more money. All right, so guys, that's that formula. The last formula that we're gonna review is compounding continuously. Do you guys remember the formula? No? PERT. There we go. Okay. P is still principal, R is still the rate, T is still the time. But we're not just compounding it once a year or 4 times a year or 12 times a year. It's continuously compounding. So your money's gonna grow faster. So let's do an example where, let's say that you're starting with $1,250. Your rate is 5.4% and your time is 6. So we're starting our initial investment at $1,250. Your rate, you must change it to a decimal. So if you move this decimal over twice, you get 0.051. Sorry, 0.054. 0.054. And your time is 6. So guys, this is what you're typing into your calculator. All right, so you guys got $1,728.31 for compounding continuously. So guys, just really quick, let me review the different formulas. This is just compounding annually. It's not daily, not monthly, not quarterly. This is just your basic growing function for interest rate. Now, if I say compounding and I give you, the actual number of times that it's happening, say if it's quarterly, daily, that's that in value. This is the number of compounding. So you'll use this one. Keyword is like compounding daily, compounding monthly. You're gonna use this formula. And if it's continuously, that's principal e to the power of RT. This is continuously. All right, those are the 3 formulas we just went over. Okay, so now guys, let's practice with the word problems. All right, so what interest rate compounded monthly? That's the key word, is compounding monthly. So I know that the formula that I'm using is this one. So I'll copy that down. And if it's monthly, I know that this N is 12. Okay. So what interest rate compounded monthly is needed for $8,500 to triple in 5 years? So I know that my initial investment is $8,500, and I want to know how long it'll take to triple. It'll take 5 years. And if I want to know the tripling amount, how much is 8,500 tripled? What do I have to do? Yep, times 3. So 0, 0, 15, 25. Okay, so I know that I want it to become that amount there. What I'm going to do first is divide both sides by 8,500. And I know that 25,500 divided by 8,500 is 3. And 12 times 5, that's just 60. I'm going to put that as 60. Okay, so we need to get R by itself. Let's get rid of this exponent. The way that I do that is I can take the natural log of this side and the natural log of that side. If you don't like ln, you could also take the log of both sides. It's up to you. You'll get the same answer either way. Okay? All right, so when I take the natural log of both sides, I'm going to use the power property, which says that exponents can come to the very front. So what I will have is still natural log of 3. The 60 will come to the front times this right here, natural log of 1 plus r divided by 12. All right, let's continue. We still want to get r by itself, so let's get rid of this 60. Let's divide both sides by 60. Okay, it's a little bit more by itself. Can you type this into the calculator and let me know what you get? Great, so that we got this, and then we have natural log of 1 plus r divided by 12. Does anyone remember how to get rid of an ln?
The E.
The e, thank you. So guys, that's what we're gonna do to both sides. Do e to the power of this, e to the power of this, so that those cancel out. So what I have now, I have e to the power of 0.01831 equals 1 plus r divided by 12. You can go ahead and subtract 1 from both sides so that you have e to the power of 0.01831 minus 1 equals r divided by 12. Guys, go ahead and type this into the calculator. Let me know what that is. Okay, e to the power of 0.01831 minus 1 is 0.018479. R divided by equals r divided by 12. And the opposite of dividing by 12 is multiplying by 12. So if I multiply that by 12, I get 0.221744. That is my rate. And if you wanted to put it as a percent, it'll be 22.17%. You move that decimal over twice. All right, so this is the rate that is needed in order to triple your initial investment in 5 years. So guys, in this problem, we want to grow 18 million to 25 million in 8 years. In order to do this, we need to figure out what interest rate compounded annually is required. So this is my formula. Okay, my principal value is 18 million. So that's 18, 1, 2, 3, 1, 2, 3, 6 zeros. And I want it to become 25 million. The time is 8 years. Okay, so the only variable I don't know is the interest rate. The interest rate, that's what we're trying to find. All right, so what I'm going to do first is divide both sides by 18 million. So those cancel out. And divide this side by 18 million. In your calculator, if you put a decimal behind one of the numbers, it will give you a decimal as your answer. Okay, so I got 1.38889 equals 1 plus r to the power of 8. Okay, from here, you either need to take the log of both sides or take the natural log of both sides. Either way, you'll get the same answer. So when I take the natural log of both sides, I'm going to use the power property. Remember, the power property says that this exponent can be written in the front. So what I will have is natural log of 1.38889 equals, the 8 will come to the front, and then you have this natural log. Okay, so from here, I'm going to divide by this 8. And this will be just a number, so I'm going to type this into my calculator. I get 0.041063 equals, that canceled out, so I'm left with the natural log of 1 plus r. Okay, I'm really close to getting r by itself. I need to now get rid of this natural log. How do you get rid of a natural log? E. So we're gonna do a base of e on both sides, and those cancel. So what I'm gonna type into my calculator, I have e to the power of 0.041063 equaling 1 plus r. We're very close. Now all you have to do to get r by itself is subtract 1. Subtract 1. So I'm going to type this into my calculator. E to the power of 0.041063 minus 1. I get 0.041918. So this is your rate. If you want to change it to a percent, just move the decimal over twice. So your rate is 4.1918%. So guys, if you want your 18 million to grow to 25 million in 8 years, this is the interest rate that you would need to achieve that goal. So perhaps you would look at stocks that historically grow this much annually. All right, nice. So I'm gonna have you guys practice for a little bit, and I'll be walking around if you need help.